5.3 Function rules, tables, and graphs. So in this section, we're going to work on graphing functions that we talked about in the last section, and we'll use tables to help us find the values that we're going to graph. Before we graph, we need to be able to identify independent and dependent variables, and these are terms we've talked about in the past. We need to remember that an independent variable is the variable that provides the input values of the function. So these are the values that are in our domain. Independent is always making up the domain. And the dependent variable is the variable that provides the output values of the function. And since it's the output, that is our range. So we have a function that's given to us here. If we read the problem, we'll see that it's about video games and the cost to rent and video games and then to operate the video game player. So we were given the function c of v equals 5 plus 3v, and we're told to make a table of values and a graph. So before we actually do any of that, some things we have to think about. If you look at the table, you'll see that we're starting with a value for v, our variable, of 0. And we have to think to ourselves, why are we doing that? Why does that make sense for this problem and what this problem is all about? Well, v represents the number of video games, and it can't be negative. So the lowest number of video games that you can rent is 0. That's why we use 0 as our first value. The second thing we have to think about, well, that I'm going to have you think about right now, are you always going to start a table with 0? The answer to that's no. Some functions, depending on what a problem is talking about, can have negative values. So it all depends on what the problem is really talking about as to what values you're going to use for your variables. So when we go to actually graph a function, we should recognize this table. We did this in the last section. So we can use these tables to actually help us find the points that we're going to graph. So if we're going to use 0, 1, and 2 as our values for our variable, those go in the first column. The middle column is where you show your work. So again, C of V, we're going to plug in our values. Again, just showing our work here. And then each of those values, you would get 5, 8, and 11. So now, one option you have is to show your work like this, where in the middle you do all of the evaluating and write what each of those is equal to. And then in your last column, you can write the point or the ordered pair that you have to graph. That you use your original input and the output you got. So this first one would be the 0.05. The second one would be the 0.18. And the third one would be the 0.211. So if we come over to our graph and we graph those three values, zero, 5, pay attention to the scale. The y-axis is each line represents 2. So if we go to 0, 5, that would actually be, well, there. Go 1, 8, and then 2, 11. We have those 3 points. Now, the natural thing for a lot of students to think is that they need to connect those with a line immediately. But now that you're in algebra, we need to actually think a little bit before we do this. We need to think, is our data, is our information what are called continuous or discrete? So write these in on your paper somewhere where you have some room. Continuous data is data or numbers that can have decimal or fraction values. Discrete is the opposite of that. They cannot have decimal or fractions, or it's not continuous. So we have to think this problem is all about video games, the number of video games that you're going to rent. We have to think to ourselves, is it possible to rent fraction or a decimal of a video game? It's not. So this is an example of discrete. Okay? So that means we would not connect with the line. So over wherever you've written this, discrete, this would not be connected by a line. Continuous would be connected by a line. So it's a little bit extra couple of things that you need to consider when you're graphing this year. So now I'd like to have you try using a table to find the values that you will be graphing. Before I have you do that, you've got to think to yourself, what values of x should you start with? The last one we started with 0 because it was all about video games, and 0 is really the lowest number of video games that you can rent. This one's not about anything. So when you have a problem that's not about any specific, I want you to start with the -2 and increase by 1 for each value. So that means you'll have, if you look at your table, you have 4 rows in your table. You'll use -2, -1, 0, and 1. So pause the video, take a second, complete your table, and then graph those points. Think about whether or not this would be continuous or discrete information, so whether you should connect it with a line or not, and then play the video and see how you did. So here's what the table should look like after you've shown all your work in the middle, found your output values on the right. So the points that we would be graphing would be -2, -2, -1, +1, 0, 4, and 1, 7. And then since this problem is not a word problem, it's not about anything specific, that is going to be continuous information, continuous data. So when we graph, this would be connected by a line, and your graph would look like this. So on the back side of the notes, all we're doing is looking at some different types of functions and what their graphs would look like. We're still using a table to find the values that we're going to graph. So here we have the function y equals the absolute value of x plus 2. It's an absolute value function. We talked about absolute value recently. And if you notice in the table, you actually already have the x values that you're using as your input or your domain. So all you have to do is take those values, plug them in, and evaluate. So if you plug each of these in, the absolute value of -3 plus 2, well, absolute value of -3 is +3, plus 2, you get 5. So that would give me the point -3, +5 to graph. And I can either graph these points as I find them, I can fill in my whole table, graph the points at the end. It does not make a difference. So if we go through and we evaluate each of these, we would have those output values. Notice you have some numbers that are the same. So if you want to write your ordered pairs, Now, if we graph these points, -3, +5, -1, +3, 0, 2, 1, 3, and +3, +5. Now, connecting these, whenever you're drawing a line, I'd like you to use a straight edge. So your school ID actually works very well for this. You have a ruler or a protractor, you can use that. School ID should be fine. You can't connect everything with a straight line. So what you need is actually two, they're called rays, where they start at a point and continue in one direction. And then make this V-shaped graph. Now we have this connected because, again, this would be an example of continuous information or a continuous graph, because this function, again, is not talking about anything in terms of a story problem. So those are automatically continuous, and we automatically connect those. Our next example, we have the function actually written in function notation. So f of x equals x squared minus 2. Again, I've given you the domain values, -2 all the way through +2. These are the 5 values that you're going to use whenever you're not given any values to start with. Those are the automatic ones that you need to use. So again, we're just going to have to complete our table, graph our points. So here, if we plug this in, now how you write these in can be very important, especially with the negative values. Anytime you're going to square a negative value, you need to make sure that negative value goes in parentheses. If you don't put it in parentheses, you will not end up with the correct output value. So -2 squared, -2 times -2 is +4, plus another 2, we have +6. So this is the point -2, +6. If I plug in a -1, again, it's a negative value, so I really have to put it in parentheses. So I have -1 squared, that's +1, plus 2, that's 3. So -1, +3 is my second point. And then I keep going down the line. 0 squared plus 2 is 2. Plug in the +1. So positive numbers, you don't have to use the parentheses. You still can if you just want to make a habit of always putting them in. It's not going to do anything bad for you. 1 squared is +1, plus 2 is 3. So we have the point +1, 3. And then plugging in the 2. 2 squared is 4, plus 2 again is 6. So 2, 6. So those 5 points we need to put on the graph. And now, before we do anything else, we have to think, can we connect these? Is it continuous? Is it discrete? Well, again, the problem's not about anything with a word problem. So we should connect these. We should treat it like it is discrete. Excuse me. We should treat it like it's continuous. But now, if you try to use a straight edge to connect these, you'll find that here's a straight line. It's always going to be straight. I can't draw a straight line through all of these points on the left side of my graph. That's because this actually is not a straight, any part of this graph is not straight. This is called a curve. It's actually called a parabola. So what you have to do is you have to just use your pencil and you have to draw a U shape. So I'll draw one side and then I'll continue the curve up the other way. Put arrows on both ends. Notice this is not a sharp point down at the bottom, it's a curve. So it should look like the letter U, not the letter V. There's no sharp point on this graph. Okay, now I'd like you to take some time and complete 2 of these graphs on your own. Remember, think about what values are you going to use as your inputs. That's determined whether or not the problem is talking about something specific and what values would make sense for what that problem is all about, or our automatic values if we don't have any information from, say, a story problem. And then at the end, before you finish your graph, think, do you have a continuous graph or is it discrete, to figure out whether you're going to connect with lines or not. So this first example, first quick check here, this is not a word problem at all. So automatically, anytime this happens, those are your 5 values for your inputs. So pause this video, complete the graphs, the tables and the graphs for A and B, and then play the video and check how you did. So here's the work that I would expect to see in the table. This is, again, a continuous graph. So we have our 5 points shown on the graph, and we use a straight edge in this case to connect those 2 sides and make a V-shape graph. Absolute values, there's a V in the name, always end up with a V-shaped graph. For part B, again, you would be using those 5 values, -2 through +2. When you plug them in, this time I showed that you can write it out with the value that you plug in always in parentheses. It will not do any harm. You definitely need to make sure you have these 2 in parentheses with the squared outside, and that's exactly how you should type it in your calculator to make sure you get the correct values. There's the output values. Again, continuous because our problem is not a story problem. So this would be our parabola, it's called. I'll have you write that down in just a minute. So graph your 5 points, draw your parabola. So your homework is the worksheet that you picked up. But before you do that, let's write a little extra on our notes. Find some empty space, front side, back side, does not matter. So anytime you have an absolute value in your function, that when you're going to go to graph it, you will always have a V-shaped graph. There is no special name for that. Anytime you have an x squared in your function, you end up with a U-shaped graph, and the word you should start trying to remember for that is parabola. That's actually the name of the U-shaped graph, parabola. There it is written out. So if there's time left in class, go ahead and get started on your homework.